And it seems that we do have only one talk before our quiz game, and this is going to be it for this Borderless.js conference. So, as you can see, time flies very fast. So, the next call is the next talk is called Gemini function calling using Google AI SDK in Typescript. So get ready to make sure that you have all the best practices from the world case scenario, right? So how you can actually use all the features of the Gemini, and you can use that to write clear functions with clear parameters definitions, work with the sort of like a structured outputs, and handle all the API calls like a pro. So Borderless.js conference going to another location. Right now we're switching from Poland to Colombia. And now I'm going to pass my mic to Carlos. Carlos, you with us?
Hello. Yeah, I'm here.
Let's go.
Yeah, thanks. Very excited to be here. Thank you. Okay. Hello, everyone. Very excited to share with you today about this topic, Gemini function calling using Google AI SDK, designed for TypeScript. And it was nice that Konstantin talked about this topic briefly in his talk. He was talking about agents, and this is very related. We are going to deep dive here in this talk. Basically, as the name of that. So a little bit about me. My name is Carlos Arboleda. As you can see, I'm a senior software engineer and an AI enthusiast, and I have been working at IPAN for over 2 years and a half now. While working at IPAN, I got the GCP developer certification. And early this year, I joined the JavaScript community, JavaScript Colombia community, as a core team member. Uh, and I also a GG organizer, this external community, Free.com. Uh, next, let's see a little bit about the content for this presentation. We will have an introduction, and here we will talk about the difference between Gemini app and the Gemini models. Then we will talk about challenges when using LLMs. Then we have a couple of definitions that are important to understand this topic. And later, we will see how to use function calling and also with code examples. Finally, if we have some time left, we will have a Q&A section. So let's go. Introduction. And here, I would like to highlight that function calling is one of the key components of agent systems. So because of that, with this example, I would like to illustrate you about the power of the function calling capability of the LLMs. So let's imagine that we bought a couple of shoots and we want to return them. So we can leverage AI assistants to simplify this process. And just by taking a picture of the shoots and sending a brief message, we can say, okay, I want to return these shoes because they are too small. And automatically the agent is going to locate the order number in your email. Then it's going to fill out the return form for you. And finally, it is going to schedule the pickup. So let's see. This is wonderful, isn't it? Of course, at this point, we still need to supervise everything that the agents do, or basically the AI is doing. But this example, I think, is pretty nice. And of course, here we are to discuss and to understand how this works under the hood. Then let's go with some definitions also. Let's understand what is Gemini. Probably most of you already know it. But Gemini is a multimodal generative model, and it is important to highlight that this is a multimodal model by from the beginning. So it was created with this purpose, and it is for Google AI, and it's trained as most of the models in a massive data set of text and code, and it can generate text, translate languages, also write a different kind of creative content and generate images, also understand images and give up summarization of the content of the image and videos also. Um, and of course, Gemini is still under development. It is in a continued improving cycle. So we continually see different versions of this model and different improvements. Then about the differences between the Gemini app and the models, and I want to clarify this because of the name, could be a little bit confusing. Uh, and is that the Gemini app is an application, of course, and it is focused or created for non-technical users. Uh, and this application is like yeah, it's a way to use the models, but it already has many other functionalities that are on top of the model. Like for example, you can integrate it with your Gmail account or with your Drive account. You can ask information or responses about your documents, the documents that you have on Google Drive, and also about the emails that you have received. And of course, this work with many others of the Google applications. And on the right side, we have the Google AI Studio. And this is an application. It's like an IDE, similar to the OpenAI Playground. And it allows us to basically try different models. You can see here we have a drop-down list that allows us to select the model that we want to try it. And then this is more focused for developers. We can play a little bit here with the models, and also it has an option to get the code, to generate the code uh, for the configuration, including the configuration that we have defined here, the system prompt if we have defined one, and other stuff. And why it is important to understand that difference. Let me show you why. Basically, if we ask the Gemini app, the Gemini application, a question about that implies to know real-time information. Like for example, in this case, we want to know what is the exchange rate between USD and COP today. The Gemini app is going to be able to respond to this prompt because it is an application and it already have a function calling implementation in it. It should be something, of course, more similar to a agent assistant, um, agent system, sorry. But if we ask the same question to the Gemini model, it could be using Google AI Studio or using any other application. It could be Olama, you can run it locally. Uh, the answer will be really different. It will say that uh, it doesn't have information or access to real-time information, including the currency rates that we are asking for. And it is going to advise us to go to an application that already can provide us with this information. Then we will face some challenges when building real-world applications with Gen AI. And we can see accessing to real-time information is one of them. But here we're going to discuss two other more. First, the inconsistent output. Even with good prompting techniques, it is kind of difficult uh, to get consistent outputs when we ask the LLM to produce it. And then they are frozen in time. It means that they may lack of some information if we ask for information that has occurred after the cutoff of the training data. the LLM it is not going to provide us with accurate responses. And the third one is that they are disconnected from the world. So basically, LLMs have no inherent way to interact with the world, and it is limited to take an action on behalf of the user. Like for example, using an API similar to to applications that we use today. But we can tackle these limitations with function calling. And the first is that function calling already provides out-of-the-box consistent outputs. So it provides ready-to-use structured output in different formats. We can use them in JSON, XML, or use plain text. And this allows us to integrate with downstream or underlying systems. Then about access like data. Now we have by using function calling we can access real-time information and using the function responses that are structured in an structured format. So we can integrate with uh, APIs or everything that we need. And we also can complete transactions. The LLM can complete transactions. So now we have the ability to take action on behalf of the user through interfaces like APIs, and we can do this after receiving the function call wherever the task can be executed. Then let's see the definitions, some definitions about function calling and how it works. And I hope this is not so confusing for you, but the definition is basically that it is a technique that allows the LLMs to interface with external systems and tools. The LLMs are fine-tuned to detect when a function needs to be called, and then output a JSON containing arguments to call the function. This can be a little bit tricky, but basically, this is a powerful technique that allows us as developers to create just descriptions of functions in our code and then pass these descriptions to the language model in the request. So then it can do its magic. But there is something that at first it was overwhelming for me, and is that the LLM function calling don't actually call your function. So the LLM doesn't have the capability to directly call your function, but you have to do it manually. This kind of depends on the SDK. If we, for example, use the Python SDK, it automatically calls the function for you. But in JavaScript, you still need to call it manually. Then, as we said, as I said before, it provides an structured framework for consistent JSON responses. And this provides us with the ability to call external tools and APIs. We will see some example before, some example later. Then let's see a life cycle of a Gemini function call. Basically, everything starts with the user sending a prompt to our application. And then in our application, we will create an instance of the model that we want to use and send the prompt from the user together with the function declaration. We're going to see function declaration later. And then when we send this information to the model, it is capable to identify if it requires a function to respond to the user prompt. Once the function is identified, it is going to respond with the function name and the arguments that can be extracted from the user prompt or even from the model information, from the model knowledge. Then in our application, we are going to invoke the function with the function name that we already have, the model already provided to us, and the arguments, and then send the response back to the model. At that point, the model will be able to generate natural language summary using the response from the function, and then send plain text response that we can send directly to the user. And something I want to record to highlight here is that this is a multi-turn uh, communication flow, conversation flow, because if we see here, we are uh, making two calls to the model. Basically, the first one is when we send the prompt and the function, and the second one is when we send the function name in the response. And because of this is binatural multi-turn conversation flow. Then let's talk about another nice feature that we can take advantage when using function calling, and it is the parallel function calling. This basically is that means that the model uh, will identify if it requires to call one or more functions. And in case it requires to call more functions, and these functions are not depending one of another, the model can send all the function calls to the application. We can execute all the functions and then respond to with send all the responses to the model. And this dramatically improves the performance, and it's a code saving approach. But let's see what would happen if we wouldn't have this parallelism. Basically, what would happen is that the model will need to call one function at a time, and we will need to respond uh, to send the response of the function, and then it is going to call the second function, and so on. And of course, this is more time consuming, and also will increase the cost because we are calling uh, more times the model. Then briefly, let's see where are the models supporting function calling. Basically, function calling is supported by the Gemini 1.5 version models. It means Flash and Pro, but it is not available in the Gemini 1.0 Pro, any of the versions. Uh, Here we can see also the ones that support parallel function calling. And also there is another feature that is force function calling. That basically means that you can force the LLM to always call the functions uh, and instead of relying on information that the model may have. Then let's see how to use uh, function calling in code. But before, let me ask you something. What do you think would be the answer if we ask the model, not the app, not the application, but the model, directly to the model, what is the time in my location, for example, in Cali, Colombia? Let's think about it for some seconds. And as you may know, of course, the answer would be that uh, the model it is not capable to respond to this question because it doesn't have real-time information, including current time. But let's see how we can tackle this limitation. Let's see some examples. This time to code. Basically, here we are going to define a function to get the current time in our JavaScript file. This function has in its definition an object containing a property called timestamp that will help us to properly return the time for the user. And here in this line here in this part that is highlighted, this is basically a helper to simplify the way that we can invoke our function when we receive the name from the model. Then we have to declare our functions. This means that we need to create a declaration using this specific format. This basically follows the OpenAI specification. And here we can define the name of our function, the same name that we have in our code, then a meaningful description of what the function does. And we can also define the properties, the parameters that we have for that function. It is usually an object, just for simplicity. And inside that object, we can define all the properties that we need. In this case, it is only the time zone. This is we can define the type. In this case, it's a string. And then we have to define a description, meaningful description. In this case, I'm including an example of the format that I want to receive the time zone. And finally, here we can define if whether the property is required or not. Then, when we have that part, we also need to create an instance of our model. And pay attention to this part here. It is important. We have to include the tools that in the model creation. These tools refers to the function declarations, not the function itself, but the function declaration. Then we also need to send the prompt from the user, and with this we can call the model to generate some content. Once we call the model, we will receive a response, and in this particular case, the response is going to be a function call. So we will receive something similar to this. And this basically includes the name of the function that we have to call and the arguments. And let's see in the arguments, the model already knows that we have this time zone parameter. And also we can see here that it's using the format that we ask it for to use. Then with this function call, we have to get, and remember the utility that I mentioned before, this function mapping here. We can use the name that we received with the function call to get the function. And once we have the function, we can invoke it and send and pass the arguments, and then use that response as the content that we are going to send later. Finally, we have to send a new request, and this is the second turn for the API for the model. And here we are sending the original prompt for the user, the content that basically refers to the function call, and finally the function response. And we send the response back to the model. After that, we are going to receive not a new function call in this case, but just plain text saying to the current time in the location requested for the user. Then let's see a little bit about data structures and schemas. Here is how we can declare different schemas, and we see that we have different formats here. The first one is the single or multiple parameters. This is the way that the one that we use in the sample before. We have in this case, we have a property that is the destination is a type string, and here we have a description, that's destination. Then we can also have a list of parameters. This means that we can receive an array in our properties. This time we have the locations. This is type array, and we also define a description for this property here. Then inside this location property, we can map the different properties that each item contains. In this case, we can see that since this is a list of locations, each of the locations components is going to have the city and the country. And both properties are required. Finally, we have nested parameters and their structures that are basically a mix of the two previous ones. Here we can start with an array. We can switch to object that is basically the definition of the properties for each of the items inside this array. But additionally, we have a polygon property. And this property is, again, an array. And so we can define the properties here. We can nest it as many as we need to define the function arguments. And this is an example of the function call that we are going to receive if we define each of those types of structures. And the first one is a simple one, just the destination with the value. For the list of parameters, we have an array. In this case, we have two different cities. And for the last one, nested parameters and data structures, we have an array again, but let's see that each of the items of the locations in the array have another array that is the polygon containing the latitude and longitude of each location. Now let's see some examples. I'm going to switch to my Visual Studio Code, and here I want to show you. This is a repository that you can access by this QR code here. Here you can find different examples about function calling in Typescript, and we are going to review some of them here in the presentation. Okay, first we have this intro example here that is basically the one that we already reviewed in the presentation. We also have an example of using data structures. You can go through them at your own pace. But something that I want to show you here within the presentation is this example that is basically a SQL Talk application that allow us to talk to our data. Basically, let's imagine that we have a database and we want to connect an LLM to the data and to execute queries in real time. So we can do this by using function calling. And here I'm going to show you. For this example, I'm using basically SQLite just to simplify everything here. And then we have this script that creates the different tables and structures that we are going to have in our database. As you can see, we will going to have a student table. Then we also have a course table with the title, content, structure, and duration of that course. Then we have the student course that basically have the enrollment of each student in the different courses that we have. And finally, we have a table for the notes of each student course, for each student and the different enrollments to courses that it has. Then let's see about this another file here that is containing the data. It's basically inserts some rows in the different tables. And here we have 3 different students, Alicia, Bob, and Kathy. And we also have 3 different courses, one for introduction to computer science, another for advanced mathematics, and another one for English literature. Then we have the enrollments here. And just to make it a little bit easy, I have generated these descriptions here using Copilot uh, that basically say that Alice is enrolled to the Introduction to Computer Science and also to Advanced in Mathematics. Bob Johnson is enrolled to Advanced Mathematics, and Kathy is enrolled to Introduction to Computer Science and English Literature. And finally, we have the notes for each of the students. Uh, Alice has a note of 4.5 for computer science, and so on. So we are going to see this data when we execute the application. Then let's focus in the interesting part of this example. First, we have the definitions for the different functions that we can use as tools for, and the model can use during the function calling invocation. We have the get tables that is basically going to get the different table names that we have in our database. Then we have a count rows function that basically counts the rows that we have in a determined table. We also have the get table schema. This is a pretty important part. This basically provides the model with the required information to build queries to our different tables. Here we only have an argument, a property that is the table name. And with this, we are going to retrieve the data structure for that table. And the response for all these functions here are pretty much JSON format. So here we are sending the name of the table, the name of each of the columns, the type, either whether the column is in the label or not, the default value, and if it is a primary key. This is important for the model to identify what is the column that it needs to use in order to join tables. And at the end of this get table schema, we are sending also the rows, the number of rows in that table. And finally, we have the execute query function. This basically will allow the model to execute queries in our database once it has the required information to build the query. Now, let's go with the declaration part. So we have here the declaration for the tables function. We also have the declaration for the table schema. We see that we are here providing insightful information for the model, including information about uh, what the function responds. And also we are saying here something pretty important to increase the accuracy of the model. We are saying that always use the names coming from the tables tool instead of just trying to come up with names by itself. Then we have the table name property, and something similar for the execute query function. And here we also have a main full description. So we are basically explaining the model how it has or what is the query format that this function expects. This should be a query that works on SQLite, and we are also saying the way that it should define the table names, basically including the data set if needed. And here we have the part, the qualified name. and the query has to be in a single line. With this, we rid off of we can get rid of parsing the query and before sending it to the to the database. Then we have the instance of the GenAI model. Then we have the functions, the different functions. This is again utility that we can use to map the different functions. And this is the tools is actually the different declarations that we have for each of the functions. Finally, this is probably one of the most important parts here. We also need to provide a meaningful system instruction. This is basically our system prompt. And we are here explaining, giving some instructions to the model about the information that it can use, something that we want it to refrain and is making up information, just basically getting information that it is not coming from the database itself, and so on. So here we also are defining the output format for the different responses. We ask it to use markdown tables and also to include a summary of the information. Then, when we create a model, we are providing here the tools. And then we have this handle prompt function that is basically going to handle each of the function calls that we receive. We also have this important part here. Basically, we are using the chat option when interacting with the model, so we can use different. We can have a track of the different prompts that the user have sent, and also we can store the information, the responses that we have sent to the model for each of the function calls. And this is important because this allows us to improve the basically the performance of our implementation. This acts as a catch for the iterations. I'm going to present it in a bit. Here we have to we are sending basically the prompt to the model. Then we are receiving here the result, and we are identifying here if we have any function call. This is in a cycle, in a loop here. And as soon as we don't have function calls, we can break this loop and then send the final response to the user. But if we have function calls here, we need to add that function call to the history and then execute each of the functions sent by the model. And here we are also considering that the model calls multiple functions using parallel function calling. This is basically it. So let me execute this. This a little bit here. I have some product samples here. For example, let's ask the model to get a list of the different students that we have in our database. And let's go through the different logs that we have here. Once I send the prompt, the next thing that is going to happen is that the model is going to respond with a function call. The first function call will be get tables. And this is the response to that function call. Basically, we are sending the name of the different tables that we have in our database. Then we have another function call that is to get the table schema for the student table. And here you can see we are sending the rows and each of the columns in that table. Finally, the model now understanding what is the structure of the table can create a query and we send the response to that query here in JSON format. And at the end, we have the final response we ask the model a summary of the response. In this case, say the database contains about 3 students, and these are the students in a markdown table. We can execute some more complex queries, like for example, asking to, but let me show you something before. If I execute the same query again, since the model already knows the table schema, it is not going to request or to call the get table schema function again. Instead, it is just going to execute the query, and this is okay because the data can be maybe changed from the last time. Then there's execute this other prompt here, and here we see that we have more calls. We have a new get table schema function invocation for the course table, and another one for the student course. And finally, we have this execute query here. This is the way the model created the query. This is the response, and this is the response for the function for the execute query function. And finally, we have here the response that we can send to the user. Let's execute one more. Here we can see this was to a query to get the average note for the students in the advanced mathematics course. It just was missing the notes table. So we have a invocation for the get schema for the table, and then we have the invocation for the query, and finally we have the response here. Okay, let's get back to the presentation. Finally, I would like to give you some more information that you can get in order to learn more about function calling. Basically, one is the repository that I already shared with you. We also have some Google Code Labs implementing Gemini function calling, and of course the Google Cloud Platform function calling in Gemini repository, containing a lot of examples, but they are in Python. Yeah, that's basically pretty much I wanted to share with you today. I hope you enjoyed it. Thank you.
Yeah, thank you, Carlos, for this amazing presentation of yours. And actually, with your last slide, you answered one question that we had about materials, about the code base examples and other things. So thank you for that as well. But nevertheless, guys, if you still have some questions later on, or if you rewatch the recording later on, Carlos will be happy to answer your question. Is it right?
Yeah, of course. Yes, get in
Okay,
touch with
okay.
me. I can answer.
Okie dokie. That's cool. All right. Thank you then, Carlos, for your presentation. So it was great talk, and it was great last but not least talk of this conference. Thank you very much.
Thank you so much. Bye bye.